Here's your log. Have you picked that up recently? I know it's been a weekend and today's Monday, but we need to focus on a new week. So you can see we have these three homework, 1, 2, 3, and that'll be a review sheet. Then there's a group quiz, and we have another review homework. So you did these three. That was our first three homework that we took. I believe this is just using your calculator on recognizing how to use inverses on your calculator with non-famous angles. Here's the Tarzan, and here's where we had to do the 3 parts. So we're continuing on with the 3 parts where we evaluate an equation by getting the angle alone, and then we evaluate the equation to get the first 3 values, and then we actually graph it. So that's where we stand. If you have been keeping caught up or you got caught up over the weekend. So turning off our lovely background music and saying hello, welcome Pelinor to our new session here of Camelot with Mrs. Brugalari and Algebra 2 Trig. I hope most of you tried to get on the live chat on Friday, and I think I'll have another live chat on Tuesday and Wednesday of this new week. So with your paper and pencil handy and knowing you've got a pause button you can review, here is what we already know. So starting off this lesson with what we know before we move forward. So we have our bow tie theorem is how we place triangles so we can evaluate angles more cleverly. Now we're going to ignore principal angles, banana and rainbow. That was the first part of chapter 13. Now we're actually accounting for all angles, so we're going to ignore that. But the bow tie never goes away. So the cosine is the positive ratio here in quadrant 1 and quadrant 2 because cosine is associated with x. The cosine ratio is negative in quadrant 2 and 3. But don't forget this positive theta going counterclockwise, negative theta going with the clockwise. We can, those are in one revolution unique angles, but if we're going to add multiple revolutions, also known as 360, several 360s, and then we can get other coterminal angles. Or if in radians, we could add 1 revolution or 10 revolutions and will be an integer. So this is going to get all of our angles. Not that we need all of them. We're just going to need the first 3 positive values. So this is the reference angle inside the triangle, but the actual angle here is negative. Maybe this is 120 degrees. This is positive 120. This would be negative 120. So our actual values rather than the reference angle, just placing the angle. And then the sine part. Sine ratio is positive. Sine is like the y, and so it's positive in quadrant 1 and quadrant 2, where quadrant 1 angles are easily. And then this 120, the sine ratio for getting all the way up here, that long leg, that value, this entire, not the reference angle, but that value is take away this angle. This reference angle here, or this is what creates the reference angle. So 180 is to here, and you subtract this out, and that's the actual angle, not the reference angle. And then the sine ratio is negative down below. Sine is like y, and so it's negative in quadrants 3 and 4, quadrant 3 and quadrant 4. So here's going clockwise is negative theta. And going counterclockwise, this value is bigger. So this negative angle, these are the same angle. So, but a minus is a plus. So this angle is bigger than 180 or bigger than pi. So those are things that we established at the beginning of chapter 13, which has been several weeks now. All right, so now following the same process we did on the last lesson, if I give you an equation, can you isolate for theta or x, degrees or radians? Can you predict this value given a value, and can you graph it? So this actually happens to be the problem in the textbook on page 782. If you want to look at the author's way of doing it, mine is a little more broken down. So here we go. So the first step is to isolate A. So we're going to take our equation and we're going to get rid of 2 by subtracting it. Then we're going to get rid of the 3 by multiplying by 1/3, which looks like division. And then we're going to take the inverse of both sides. And then still continuing to isolate the angle, or this whole thing represents the angle, but isolating that variable theta, multiply by 1/4, and then subtract the 31. So there's my equation for isolating the variable theta. This entire thing here, the entire thing here actually represents, we can see right there, that entire thing represents the angle. But there's a lot of things that have been done to it. So now we've isolated that thing that acts as the argument, acts as the angle, using the variable theta. So there's our equation. Now that particular one, the textbook says to go back and look at this again by taking the equation we've created part A to evaluate it where y value is 1.5. So we can just continuing on and covering so that you're not overwhelmed, one step at a time. So part B, this is the original in the textbook. Here I have modified it to get theta alone. Here's typical, and here's theta alone. So now our goal is to find the first 3 positive values of an angle where the y value is 1.5. So we're going to plug in 1.5 here and find 3 positive values, the first 3 positive values, not just random, but going in order. So to do that, we first plug in the 1.5. And then once we plug in the 1.5, we simplify with your calculator. So 1.5 minus 2, enter, divide by 3. We're going to get, actually, that strange decimal is the fraction -1/6. So now we're looking to evaluate, what is this? This thing here I need for my I need to put that into my calculator. So this is going to be where my calculator comes into hand. So when I use my inverse key on the calculator, the actual angle, and did you go to degree mode? Because it's in terms of theta, so you need degree mode. This is rounded. The decimal you probably came up with is 0.59. Depending on how you round this, I did go degrees and minutes. You may keep the decimal, that is fine. I'm doing this step a little bit harder, but the decimal is actually fine. So depending on how you round that, this is either going to be 35 minutes or 36 minutes. I just left it as 35. So this entire value here is 99 degrees and 35 minutes. So I'm going to plug that back in. So I'm looking for all my theta. So here's the one unique value, 99 degrees and 30. Oh, I have 36 minutes. I must have changed the rounding. So I did. So I did change it. Over here you can see in my sketch drawing. So here is the 99 and some odd degrees going counterclockwise. There's my positive angle. And this is a negative ratio. So the other place that cosine is negative is down here. So cosine being like x is negative in quadrant 2 and quadrant 3. So I've drawn both positions. So that's positive 99 and some odd. And this is negative 99 degrees and some odd. So there it is, that unique angle, plus the 99 degrees and 36 minutes minus 99. So that represents 2 different angles. 2 different things. That's up in this quadrant coterminal, and that's coterminal here. So I'm going to start adding 1 revolution to that. So any angle that is overlapping here by adding a revolution is going to be all angles that are related to this one. Now, having replaced that, here's my 1/4 and here's my minus 31. So what do those actual values of theta look like? So I'm doing that arithmetic very carefully. So 1/4 of 99 and odd is right here. And then 1/4 of 360, or 360 divided by 4 is 90 degrees. The 1/4 only affects that. And then don't forget, we're going to subtract the 31 from positive 24, and we're going to subtract 31 from negative 24 eventually. So we're going to let n equal 0. So where are we right here without going any revolutions? Well, if n is 0, this term is gone. So it's just 24 degrees and 54 minutes minus the 31, which is going to be negative 6 degrees and 6 minutes, or your decimal value if you chose to do that. Okay, that is n of 0. Now, if I did n of 0 on the negative 24 degrees, well, I know minus 31 is going to make it more negative, so I'm not going to bother putting in n of 0 for the negative version because it just makes it more negative. 24 minus 31, so I'm just going to do just the positive angle at n equals 0. Now I'm going to actually make it 1 revolution. So put in an n value of 1. And so if this is 1, we have for the positive version, 24, 54 plus the 90 minus the 31. And we get 82 and some odd. And now I'm going to go to the negative 24, still at n equals 1, but add 90 degrees, 190 to the negative 24. So adding 190, negative 24 plus 190 minus 31 is this value, 34 degrees and 6 minutes. So I've taken 1 revolution. Now I'm going to go to a second revolution, so I'm going to make n equal to 2. So n equal to 2 on the positive angle, 24 degrees and 54 minutes, plus now 2 n's, 2 revolutions, is actually going to be 180 degrees, minus the 31, and you'll get 172 degrees and 6 minutes. Then go to the negative angle and double that up again. So I'm going to put 2 in here with the adjustment of negative 24 plus 180 minus 31. So here's my negative angle plus 2 90s minus 31, and I get this. And going back and looking at the systematic list, this is negative, I don't want it. Positive, yay, positive, yay, positive, yay, positive, yay. That's the biggest positive, so I'm going to toss it out. Here's 34, followed by 82, followed by 124. There's my first 3 positives, and that's how we write that. Not sure exactly how the back of the book writes that. Oh, crappy doodle. I was thinking too hard. All right, you need to pause the video and go back. So here's n is equal to 0. Here's n is equal to 1, which I applied to both positive and negative. Here's 190 and 190 on the positive and the negative. Now n equal to 2 on the positive and the negative. Here's the positive with 2 90s. Here's the negative with 2 90s. There's my angles. And there's looking at the size of them. Positive, positive, positive. That's a positive 2, but these are the first 3 positives. And there's my values. Where is Pelinor? He's outside. He's just tired of all this. He's as tired as I am of this video stuff. It's very challenging. Okay, so now we have got our first, part B is finding the first 3 values, and we'll verify that on our graph. So part C is actually going to sketch the graph of the original and verify those 3 values. So here's my original. All right, sliding that all the way up to the top so we don't, whoopsie, went too far that time, overly enthusiastic. All right, so here's your amplitude. Here's B, C. So this is going to start on the negative side of the y-axis and up 2. So I evaluate all those values very nicely. Here is my amplitude of 3. Period is related to B. B is 4. Now it's degrees, so 360 divided by 4, I get this 90 interval length. 90 is divided by 4 is going to be our decimal. We're going to start at left 31. We're going to go up 2. So since this is in degrees, I don't have to worry about the interval length and 31 matching. I'm just going to start at 31. Here's my 31 and start adding. So left 31 is starting at negative 31. Add 22.5, add 22.5, add 22.5, and add 22.5, and one more 22.5. So there's my tick marks. 1, 2, 3, 4, 5, 6. Why do I have 6? 1, 2, 3, 4, 5. That ends one cycle. but I went all the way up to 81 and even higher because I recognize this problem. I'm actually going to have to see 82 degrees and 124 degrees from the part B. I want to verify that those actually fall on top of this cosine wave. So I went further. So 1, 2, 3, 4, 5. Here's our traditional 5 tick marks, but I went further to encompass the 124 degrees. So you label your graph, and here it is. Here's my negative 31, and here's my next tick at negative 8.5, and then here's 14, and then 36.5, and then 59, and then 81, 104, and 126. So I'll cover this 124 up here. Then my black dots represent the parent graph before I go up to. So here is amplitude of 3, and cosine curve starts high. And then here at negative 8.5 is neutral. And then at 14 is the minimum. 36.5 is neutral. And here's the end of one cycle. Here's our traditional 5 ticks. Bad girl, I should be counting the black dots. So here is 3 down to neutral, and then here's 3. So I think my purple graph is not right. Oh, so I connected the wrong dots. So because here is my black dot, and I should have connected my purple dot. And then my next black dot, next black dot, next black dot, next black dot. So the black dots are the parent, and now we're going to have to do, what color am I going to have to do? I guess I'm going to have, let's do orange. I think orange will show up from you. So our parent graph is here. This is parent at 3, parent, parent, and I picked that up on the purple one. I should not have done that. And here is parent, and here's parent, and then continuing on, parent, and then down here is parent, and then up here is parent. So now when I look for the up to, so this is up to, x up to, started out well, x up to, that's the graph, x up to, oh, I got this one. And then here, x up to, I got that one. So this is the one I skipped. I missed that one. And then x up to, yay, I got that one. And then here is my x up to. I missed it. That, I should have picked up that point. And then x up to is here. So I missed the 2 low ones. So this curve should have gone down, around, around, down. There we go. So ignore that part. So there's the proper graph. And then my maximum 3 up 2 is 5. Negative 3 up 2 is negative 1. And my D value here is at 2. That would be my neutral, my new neutral. And then I'm verifying these 4 points or 3 ordered pairs. So when I look at y equals 5, you can see that I've drawn in a line at y equals 5. And that's here. So 1, 2, 3, 4, 5. Y equals 1.5 is what we substituted. We're asked to substitute in. So here is 1.5. So here's 1, 2. 1.5 is in between. So when I look at these values, am I creating those interesting values? Let me see if I have a better see-through ruler. Okie dokie, I think we can see through this enough. So we're trying to verify that here at 1 point, here's 1.5, laying the edge down, that I'm getting those points. So this value here is where we're hitting the orange curve, and that must be the -6. Can you actually see the -6? Let me put it back up here. So -6. This right here must be -6 degrees. And then continuing on right here, that is my roughly dropping down, that's my 34 degrees is right here. And then continuing over here, that intersection of the horizontal line with the wave reading down, that must be my 82 degrees right here. And then continuing over, intersection of 1.5 with the graph and reading down, that's about 124. So you can see that those intersections did create the values we found algebraically on the graph. Oh, I need to go home. So I'll pause the video, go back and check, pay attention to the details and your labels and your increments as usual, and take it one at a time. That's why your homework is only 3 problems, problems 3, 6, and 8, so you won't have too big of an issue doing that. All right, I will see you with the next lesson.